So this would be about as involved as a projectile motion question would get for physics 20. Okay? We actually once, when we had IB here, okay, the International Baccalaureate program, it's like crazy hard. We actually had a projectile motion question where the person fired the projectile from an elevator that was moving upwards. Oh yeah, it takes like an hour, okay, for like someone who's good at physics to do that question, because you've got all these extra factors. You've got the projected velocity and its vertical component added to the fact that you're moving upwards, which you have to add to that initial vertical component, and then you got to figure out how far from the base will it go based on how high were you when it was launched. Like if there, yeah, Mr. Dickey and I sat down and really played around that question for a long time, and then decided we'd make our students do it. Well, that's like IB will throw stuff like that at students. Like, 'cause we don't make the tests, right? When we had IB here, the test isn't made by us. Okay? It's the IB test, and they would throw questions like that. We're like, oh my gosh, how's the kid supposed to do this? Took us in for it. It's not hardly fair. Okay, some kids are real smart, I guess. Real smart. SMRT. Okay, so. Ball rolls off an incline. So we know that this incline is actually sitting on top of something else. Okay, we've got like this situation. Ball's going to do that. Okay. We know that this distance is 1.4 meters. We know that the projected velocity, so this is going to be this is 30 degrees here, and 12 meters per second. Right? So that's what we know right now. I'm still going to do this like any other projectile motion question. I'm going to break it up into vertical and horizontal parts. I know that the horizontal distance traveled is 1.4 meters. Okay, and I know from the vertical perspective that the acceleration is negative 9.81 meters per second squared. Can I still calculate V horizontal and VI vertical? Yeah, that doesn't change. I still calculate those in the same way. Okay, so VI will be the sine of 30 times 12, so VI will be positive 6.0 meters per second. Okay, and I can still calculate V horizontal, right? Cos of 30 times 12. So 10.39 meters per second. All right, so I'm trying to find the vertical displacement here. What do I need? Okay, if I had VF, I could do it. There's another way to do it, because there's no way for me to get VF right now. Right? I have VI and A. That's it. I can't get VF with the information I have right now.
I can get T.
I can get T using the horizontal information, right? I calculated how fast it's moving horizontally, and I know how far it went horizontally. It landed 1.4 meters from the base of the incline, which means it only traveled 1.4 meters horizontally. Okay? This thing was not in the air very long. This incline is probably not very high off the ground. Okay? So I can calculate T. T equals D over V. All right, so that's going to be 1.4 meters divided by 10.39 meters per second. So this thing's only in the air for 0.13 seconds. Okay. So yeah, not very long. Okay. All right, so 0.13 seconds. All right, so I need to figure out, this isn't going to work out. I must have picked bad numbers. All right, let's finish the calculation. So I'm looking for D. I've got T, A, and VI. So I'm going to do this. D equals VI times T plus 1/2 AT squared. And I don't have to manipulate anything, I just need to plug in. So 6 times 0.13 plus 1/2 times negative 9.81 times 0.13 squared. It might work. I think it's going to come out to a negative number though. That's what I feel. Okay, 6 times 0.13 plus 0.5 times negative 9.81 times, well, I should have used the whole number. Hey, I messed this up. Oh, no, it worked. Okay, so the end of this incline is that high off the ground, 0.7 meters. Okay, so yeah, it doesn't take long for it to get back to the ground from there. Okay, 0.72 meters. Okay, is it still, like, are we still going through kind of the same basic steps? Yes, we hadn't used that formula yet for one projected at an angle. Doesn't mean we can't. It just depends on what we're given. In this case, we were given a very different set of initial information than we previously been asked. Okay? Every other time it was, well, they're level, right? It lands and is fired from the same level. All that changes is you've got a vertical displacement that's not 0. Okay? In all the other cases, the vertical displacement would have been 0. All right? Okay, so now you know what one of those looks like. It's not significantly more difficult than what you were doing. You just found time with the horizontal information instead of the vertical. All right, in your digital workbook are some projectile motion problems. Okay, I'll pull them up here on the screen, but you can check them out. They're near the end of the booklet, kind of right before the unit exam review stuff. Right? So I want you guys working on those. It starts out with some horizontal ones and then moves to some angled ones, so maybe you want to alternate. And I'll just bring it up here. Did I guess the right one? No. I guessed the right one. Okay, so it's on page 9, okay, bottom half of page 9, and goes on to page 10. So like I said, the first 6 are all thrown horizontally, and then 7 through 16, I think, are all thrown at an angle. Okay, and there's a range of types of questions in there, so you know, you don't necessarily have to do them in order. Right? You might want to just try a few at random. Okay? If there's ones that give you trouble, let me know, okay? And we'll go through them together. But today's kind of a day for you to ask me questions if you're struggling with something, and okay, we can go through any that you ask for on the board. Okay, so on number 11, we got an object thrown from the ground into the air at an angle of 30 degrees above the horizontal. Okay, the object reaches a maximum height of 5.75 meters. At what velocity was it thrown? So I'm looking for the hypotenuse of this triangle. Okay, and I know that the maximum height is 5.75 meters. How fast is it going right here? 0. Okay, that's the trick to this question. Is I have to remember at the maximum height, the vertical velocity is 0. So that means that from a vertical perspective, and vertical is all I need here, okay, A equals negative 9.81, right? VI, we don't know, but it's what we're going to solve for. VF equals 0, and our displacement is 5.75, and that's a positive number. So I'm going to use this formula. V VF squared equals VI squared plus 2AD. And I'm going to use it to get VI. Because if I have VI, I have one side and an angle of the triangle, and I can use it to get the hypotenuse. Okay, so I'm going to go VI will equal the square root of VF squared minus 2AD. Okay, so I'm going to have 0 squared, and I'm not getting rid of that because I need to have that in there when I subtract 2 times negative 9.81, because I need to subtract a negative so I get a positive number, otherwise the calculator freaks out about taking the square root of a negative number, times 5.75. Okay, so square root of 0 minus 2 times negative 9.81 times 5.75. All right, so that gets me a VI of 10.62 meters per second. Okay, since that's the opposite side of the triangle, I would use sine to get the hypotenuse. Right, because the sine of 30 degrees is going to equal 10.62, my opposite side, divided by the hypotenuse, which is what I'm looking for. Okay, so when I swap these, I'm going to go 10.62 divided by the sine of 30, which is 0.5, so basically I multiply this by 2, and I'll have my answer, 21.2. Does that make sense? Okay, any other ones, guess? Don't be afraid to ask.